Good day all. I hope you all are safe and sound at home. I wish you all the best and stay healthy and stay safe. Coming to my 9th lecture, my last was regarding, in the hydrodynamics was regarding the transverse thrust. Today, after so much of feedback, with so many candidates, to a certain extent, few newly promoted masters also have asked me if I could ponder some points on the anchoring. I do understand that anchoring somewhere down the line has become now kind of a critical operations. There have been many mishaps down the line as we go back in few incident investigation reports. So, I have jotted out a few points and I'll explain them in details as well. Before that, we must remember, when we talk about the basics of the ship handling, we have the internal forces, that is the main engine, the thrust, the rudder, the ship shape, and the ship's maneuverability and the maneuvering conditions. The second factor is the external forces, which are wind, current, swell, sea, tide, all inclusive, accruing to the external forces. A good practical seamanship requires, if a mariner clubs in together, we know we cannot change the external factors, but if we can use the external factor to our advantage to optimize our maneuvering capability, because our ship's maneuvering capability, thrust, the engine movement, the rudder movement, the turning circle, everything is fixed under laden ballast conditions, etc. But the variables are the weather. So if we can use the weather in our favor to optimize, that will give us the best result as far as the ship handling and maneuvering is concerned. So far in my previous lectures, I've discussed loads of things. How does the interaction between the vessel takes place? How does the squad behaves? What is the effect of restricted waters? All these things. So starting with the basics, now I'm gradually coming and shifting my focus onto the ship handling after I believe I've been able to clarify the basics of the hydrodynamics, because the ship moves on the water, over the water. So coming to the anchoring thing, I will first go with the bullet points, then I'll explain. As I said earlier, for anchoring the external weathers, what we have is wind direction, speed, swell, tide, current. I've written here stern kick, I'll talk about it a bit later. The depth, the scope, and the shallow water patches. The weather forecast, what we do get it, and the contour. This also I'll talk about it, basis which I've drawn this figure. Let's term this as figure number 1 because there's only one figure. So, the figure number 1 is depicted with a ship with the anchor, the chain is laid down, we'll talk about it. This is the contour I've shown. The vicinity of submarine cables, before we anchor we have to see all these things. The heavy swell which we may not encounter. The nature of the seabed in which we are anchoring, of course, we'll talk about it one by one. Factor, wind, direction, speed and swell, of course. If the wind direction, it's a thumb rule. As per the International Association of Classification Society, now because of so many mishaps are happening where the vessels are trying to sustain a wind force over and above 6 plus. Ultimately, the vessel anchors are not designed to hold such a bad weather when the wind force exceeds to barefoot force 6 and above. Even at 5, if the swell is more, the wind speed is less. This is again at the master's discretion if he wants to pick up the anchor and go to a safe place for drifting. Remember, anchoring is just kind of a stopgap arrangement when the vessel is either awaiting berth or awaiting for some other reason. In case the weather deteriorates, the first thing what should be done is to pick up your anchor and go and drift to a safe location, because that time you're mobile, you can move out anywhere. But in case you get stuck with the weather and for God forsake you cannot pick up your anchor, you are stuck. Many times it has happened just because vessels are stuck in the bad weather, and then they have to, forego their anchor from the bitter end just to move out safely from that location, because you cannot jeopardize the vessel just because of anchor. So in case there's a choice to basically sacrifice or compromise, one would definitely compromise for an anchor. Of course, there are later on the anchor, if it can be retrieved and recovered and can be fixed back, or some repair thing has to be taken. That's not my perspective for this particular lecture, so I will not deviate more into that. So wind, of course, the mother nature, we cannot obviate, we cannot undermine the mother nature. When we talk about mother nature, means the weather. The second is tide and current. Of course, we have to see, because when the vessel is approaching towards the anchorage, she always stems the tide or the wind, whichever is the stronger, because it's a vector. If the tide is coming, setting into one direction, and the wind is from different direction, whichever is the stronger, the vessel will head on to her. So when the vessel is coming, proceeding towards her anchorage, of course we check the wind, the current, whichever is the stronger, we try to head into her and drop the hook. Now coming to this, I've discussed now the depth and scope. The depth, of course, we see the vessel when she is proceeding towards an anchorage, she has to have a safe depth with respect to her draft. That is one. Number two is the scope. Scope is around 5 to 6 times the depth. Let's say if the depth under the keel is 20 meters. I'm saying depth under the keel, not the total depth, because the vessel also has a freeboard and also has the stem. So all those things taken into account. The depth or the UKC you have, let's say, is 20 meters, because you also lose or compromise some chain coming out from the bow, from the eye of the eye from where the chain is paid out. So let's say the depth is 20 meters, the scope should be approximately six times. So that is 120 meters. 120 meters divided by 27.5. So that will be, say, around 5 odd shekels approximately. This is in a fair weather condition. Coming to contour. As I said earlier, I've been a mooring master, plus I've also audited many ships. Plus, when I go to anchorage, I've seen many ships anchored close to the contour. This line I've drawn is as a contour. Now what happens? Let's say this vessel is just about barely one cable away from this contour, which is approximately 185.2 meters. Now let's say this is 20 meters contour, and this is on the shallow side and this is on the deeper side. This side, let's say it is coming to 50 meters contour. What may happen? In case the wind force increases, the vessel cannot sustain her anchorage even after paying out extra cable, and if she starts dragging into this direction, what will happen? The anchor will drag into the deep waters of 50-meter contour. You can imagine what will happen. Impact will be so strong that the vessel will not only damage the vessel, the bow, but will definitely, there is a probability for her to lose the anchor. So I repeat myself. The vessel is, let's say, inside 20 meters contour, this vessel, this is the contour, and this side the depth is 20 meters approximately, and on this side it's more than 20 meters, let's say about 50 odd meters. The distance from here to the contour, let's say, is one cable, which is 185.2 meters. In case the bad weather starts coming in, what will happen? in case the wind comes from this direction and the vessel starts dragging the anchor into the deeper contour, what will happen? The anchor will go and fall into the deeper water. You can understand such a jerk will come, which will definitely catastrophically compromise the cable and maybe the bow also. There are chances she may get damaged, besides the damage to the windlass respectively. So this is something which you see from the practical seamanship, which you may not find in many of the books what I've just discussed with you. The other thing, same yardstick is to be taken when the vessel is anchoring in the anchorage area where you may have submarine cable. Give at least, subject to your swing circle. Let's say my vessel's swing circle is 2 to 2.5 cable. I will give at least safely, if I have a possibility, at least about half a mile. At least about half a mile. But more the merrier. So in case the bad weather starts setting in and I start drifting towards the submarine cable, I still have certain amount of time to kick my engine, and if I can pick up the anchor, run away, I don't damage the submarine cable. Again, another aspect which we mariner forget. See, sometimes what happens that the wind speed is not much and the swell is quite a bit. Why? Because there might be a storm, say around 300 some odd miles. The wind speed may not be much. It might be force 3 or force, Beaufort force 3 or force. But the swell generated may be more. If the swell is more, the vessel starts surging up and down. In that case, what is happening? The catenary, which is laid out when I talked about the scope, is getting disturbed. So somewhere down the line, the anchor is also trying to get, it's getting a dragging moment because the chain is bouncing up and down because of the swell, because of the vertical movement of surging up and down because of the excessive swell. So just be cautioned about this in case the swell is more, and if you find that the vessel is pitching or rolling, by virtue of which the cable, the anchor cable, is making an angle of more than 20 degrees. In other words, the cable is stretching to a very long stay. That is definitely disturbing the catenary, and because of that there is a very high likely probability that the vessel may perhaps drag the anchor. The last but not the least, when I'm talking about the external factors, is the nature of bottom. Sand is a very good holding ground. If we see which is marked on the chart, and if it is sand, yes, definitely it's a very good holding ground. Mud, not so much, because when the vessel drags, it just pulls out. The flukes do not dig in properly into the soft mud and they keep dragging. But in sand, being a kind of a solid thing at the seabed, once the flukes are dug into the sand, it holds on to that. Because remember, many a times when I have spoken to my colleagues, and a few of them, I'm not saying all of them, they are of this kind of opinion that, when you are anchored, it's the anchor which holds the vessel. Well, I would beg to differ on this, which is actually also a fact. It's the catenary which is laid out. The catenary, the weight of the chain, when we talked about the scope, in this particular example, 20 meters is the UKC you have depth, you must pay out at least 6 times the depth of the water, so that about 120 meters. And of course, if the weather is more, you need to pay out more. Because if the catenary is not disturbed, the vessel will hold her position at anchorage. Coming to the other aspect. That is when I talked about the 2 factors which are governing the vessel maneuverability, is external and internal. Now we talk about the internal factors. First and foremost, as per the IX, the rate at which the windlass can pick up the anchor in a vertical direction As per the International Association of Classification Society, it's 0.15 meters per second, which also accrues to 9 meters per minute. At the same time, maximum depth it can take is up to 82.5 meters, means 3 shackles. In other words, if the anchor is right down up to 82.5 meters as per the IX, the windlass should be able to pick up the chain when the anchor is not resting at the seabed. The anchor or the chain is up and down. 82.5 meters at the rate of 9 meters per minute or 0.5 meters per second. Now, looking at this, we have I've written here approach speed. You see, many a times I've seen the ships are approaching the anchorage at a very high speed. Why? Because there's another vessel which is approaching, probably they're heading to the same point to secure the berth of anchorage. So one vessel will speed up just to have kind of a tug of war situation, by virtue of which they are heading for the same position. What I would do, I would still hold on, pull my speed back. There have been many cases of collisions because of these things. Worst case scenario, if I do not get a safe anchorage as a master, I would exercise my master's overriding authority by drifting. Under no circumstances, and I'm telling you honestly, I'm sharing you with my own experience, many times the charter party says that, okay, you must anchor before you tender the NOR. What one can do in case you find the anchorage is not safe, there is not space, or there is not enough depth, you go to the safest point up to the anchorage. If the charter party says, for the master's perspective, I would come, I've done many times, I've come up to the anchorage, marked the position that I've arrived this anchorage and tendered my NOR, then I went safe back and started drifting within the VHF range of the port control, and they have also been notified. Remember, under no circumstances, the commercial obligation shall not govern the safety and security of the vessel. So, talking about the speed, a thumb rule is, when you are within 3 to 4 nautical miles of your designated or your chosen anchor position, your speed to the distance ratio should be 1/2. Starting with 4, let's say if I'm 4 nautical miles away from my designated anchor position or chosen anchor position, my speed of transit shall not be more than 8 knots. When it is 3 nautical miles, I should be approximately 6 knots. When it is 2 nautical miles, I should be approximately 4 knots. When it is 1 nautical mile, I should be approximately around 2 knots, subject to if I can hold my head, subject to weather also. But approximate speed over ground around 2 knots on many of our ships. Under the laden condition, they pretty well hold. This I'm sharing with my own experience. Unless, of course, the wind is gusting, it is force 6 or something, then obviously, as I stated earlier, if I had to go, I would rather prefer to take a U-turn and go away from anchorage. I'm not going to anchor in wind force 6 and above, definitely. So this I'm talking about the calm weather condition when it's about force 4, maximum 5, and I will be able to hold her head up to 2 knots. So coming back to the thing what I was discussing, I would take the factor, the thumb rule of factor, when you're approaching within the close proximity of your anchoring position, its speed to the distance is 1/2. In other words, if the distance is 4 nautical miles, the speed should be approximately 8 knots. When it is 3 nautical miles, it should be 6 knots. When it is 2 nautical miles, it should be 4 knots, and when it is 1, it should be 2, and vice versa. I also would like to share with you one thing, and I'm not exaggerating when I say so. Most of my ships, as a master, I'm still sailing as a master. I have tried to refrain using stern thrust. Not that I don't want to use it. I try, under the fair weather conditions, to equalize the forces, to optimize my maneuvering in order to use the lesser engine as possible. Yes, under those circumstances, I had to give short ahead kicks. Remember, the old school saying goes like this: slow speed maneuvering is the best way you can maneuver and control the ship. Slow speed control is the best way to control the ship, because you can always increase the speed. But in case of any God-forsaken emergency, if you have to reduce, you may have to go crash a stern. Maybe your stern kick may fail. Maybe your engine may not be so effective, especially in shallow water area. If you have to give a crash a stern for some emergencies, okay, emergencies do happen. That is something which is not, it has happened all of a sudden. I do agree. But we do not create an emergency by going at a higher speed. That's what I'm trying to put forward. So, the approach speed I've talked about should be approximately 1/2. And identification of safe anchorage, the master decides which is the safe anchorage, whether the anchorage is safe or not, as I said earlier. The next thing is swing circle. The swing circle also has to be checked, that before we approach the anchorage, let's say my vessel length is 183 meters and I'm going to pay, let's say, about 6 odd shackles. So the calculation will go like this: the length of the ship plus 6 shackles are paid out, that is 27.5 multiplied by 6 divided by 1852 will give me approximate cable of swing circle. When we talk about that, I've taken the chain straight, that is, the chain is completely stretched. So at that point of time, what will be my swing circle? It will be approximately, what I can recall, will be around 2.1 cables approximately. So within this swing circle, I must make sure that there is no vessel around me. That is, in case I start dragging my anchor, I should have enough time to pick up my anchor and move away towards a safe position. So that is the importance of swing circle. Now, we have two ways of anchoring. One is letting go, the other one is walking back. To be very honest, what I feel and what I do, I'm not implicating that everyone should do, but then from my perspective, I always walk back the anchor. First, what I do is I walk back the anchor to about 1 meter above the water. Of course, in case of any emergency, I would let go, definitely. But under the normal circumstances, I have always preferred, and I have always done, what I've done is to walk back the anchor. At that point of time, the vessel speed, when you are walking back the anchor or somebody else who wants to let go the anchor, the vessel speed shall not be more than 0.2, max up to 0.3, because beyond that, the windlass will not be able to sustain the stress. So, at the time of anchoring, the speed of transit, the speed over ground shall not be more than 0.2. Let's take that benchmark. So that's where the slow speed control comes into picture. When I said earlier, the thumb rule is 1/2. That is 4 nautical miles, 8, and when you come to 1 nautical mile, it should be around 2 knots, and then you start reducing. And how you can reduce is that when you're turning into, or when you're stemming the tide, or when you're turning into the wind, automatically, once you're heading into the wind, the effect of current and wind will automatically come on your stem and it will start retarding your speed. Many a places, or many a times, vessels have had problems of losing the anchor, or having some problem, or damaging the cable, or the fluke or the shanks, the reason being, suppose I'll give you one very good example. I used to go regularly to Foley, that is London, in UK. There, the tide is, in the English Channel, it's approximately sometimes around 6 to 6.5 knots. So obviously, many times you have to proceed at around 8 knots, because when I'm stemming a tide or the current of 6 knots, I have to overcome by at least 1.5 knot, even in the close proximity. And at that point of time, of course, it is not safe to anchor, but for a very short duration, or if you have some very short operation, yes. Otherwise, it is recommended that it is not good to anchor under those circumstances. This, when I say I'd anchored for a very short time, and of course my main engines were ready and anchor cables were checked at all times. So the mistake what had been happening, that when you're stemming a strong tide, let's say 3 or 4 knots or maybe more, you come, you anchor, and you say, oh, now I anchored, I have to give a stern kick. The moment you do that, you can understand what will happen. As it is, you're stemming the tide of 4 knots or 3 knots or 5 knots. You've given a stern kick because of the old notion that yes, before anchoring, we must give a stern kick. That's a wrong notion. You must always check the speed over ground. If your speed over ground is your dead stop, you are at anchor position, just go and drop. And under the conditions where you have you're stemming strong tide, you may have to give a thrust ahead, you may have to give a head kick, dead slow ahead, up to dead slow ahead, and maybe up to slow ahead for a very short time. That is, situational. That has to be checked. The reason why I brought this point is to clear the notion that, because of anchoring or I'm anchoring, I must give a stern kick. No, it is again situational. And as I said earlier, I try my level best with my aptitude of ship handling. I try not to use the stern kick. Of course, if I have to use, I know I always have. So I try to say, in a layman's terminology, I try to conserve my ship's brakes. So, once we have walked back the anchor cable, I'm saying in this case, if you're walking back, you walk back, let's say, if the depth is 20 meters, coming to the same example, what I would do, I would walk back to 3 shackles on deck. When the ship is stopped, it's 0.2 knots speed. I would walk back to 3 shackles on deck and then wait for the cable to stretch. And if I find this cable is not stretching, perhaps I may give very short stern kicks, because it is very important to lay the catenary. As I said earlier, the catenary is the one which is holding the vessel. So what I would do, come to the anchor point, speed up to approximate 0.2 knot or dead stop. I walk back the anchor cable to 3 shackles on main deck. Then I wait. Because of the tide, she may fall back aft. That is, if I'm stemming the tide. In case not, the effect of tide is less, or if it is slack water, or if it is coming to slack water, I will give short stern kick to lay the catenary and gradually keep on paying the cable to what I've decided as per the scope, 6 shackles in the water, or 5 or 4, whatever the case may be. So, this is very important what I talked about. Again, this is all the practical seamanship. You may not find these things in the books. I believe so, because I have not come across that. How should we go about it? Now this third point which is the most important, dragging the anchor. Now, as I said earlier, the anchorage area is not for permanent basis. It is not that you drop the anchor and you say, okay, now the vessel is anchored, I can go and sleep. No, it has to be monitored. The chain has to be monitored at least. Once an hour, or maximum twice an hour. And the weather reports to be checked. The tidal currents, tides to be checked. The effect of swell, if it enhances what I said earlier, that also has to be checked. In case the wind force exceeds 6 knot, Beaufort force 6, it is advisable. Rest is that, master's prerogative. it is advisable to pick up the anchor and go to a safe location if it is feasible. Now, dragging, if the vessel has started dragging for some reason, the first indication is the yaw. That is the first indication you will have. The vessel will start yawing. The moment you see that she's yawing, means turning from port to starboard, starboard to port, that is the first indication that she may start dragging. At that point of time, send somebody forward, ask him to monitor the chain, the cable. If the chain is exceeding over and above 20 degrees angle, means it is high time to take an action. If you find that you are safe enough, you have enough sea room to move out, and it's not a congested anchorage, okay, you can pay out a bit more to ease off the tension on the cable. And again, monitor after you've paid out the cable that it is not stretching. Second is the surge. As I said earlier, in case the swell increases, the vessel will start bouncing. Of course, again it is disturbing the catenary. That is the second factor to be checked. That is, in case the vessel is rolling quite a bit or pitching quite a bit, that's the time it's to be checked. And this same thing what I said, under these circumstances, whether she's yawing or she's surging, when the angle of the chain goes more than 20 degrees, it's time to attend to it. And under those circumstances, a normal good seamanship or the practice is to keep the engines ready at short notice. What I would do, even at anchorage, I would keep the engine room manned, because you do not know when the emergency sets in. So, I hope I managed to explain whatever the practical aspects of anchoring, because anchoring has become very critical, as we see in a lot of incident investigation reports. Many places, the anchoring, the vessels are having kind of accidents or incidents during anchoring or at anchorage, either while approaching anchorage or while moving out of the anchorage. Thank you very much for your listening, and please do come back with whatever feedback you may have. Like for this particular one, I got the feedback for an anchor, ship handling and how to anchor safely. I have managed to impart whatever practical knowledge I have. I thank you all again. Please do visit my YouTube channel, Marine Quest Solution, and press the bell so you keep getting the notification, the icon bell, and do the same thing for my Facebook page. Thank you very much. Good day.